Welcome to Simultaneous Equations Level 4. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving y equals 2x plus 1 and 3x plus 2y equals 58. Now looking at the first equation, we can see that this is written with y as the subject. And often when this is the case, it's easier to solve these equations by substitution. And the way that we can do this is we can say that if y is equal to 2x plus 1, we can take 2x plus 1 and substitute it in for y in the second equation. So this means that the second equation, 3x plus 2y is equal to 58, becomes 3x plus 2 times, and we can now substitute y for 2x plus 1 from the first equation, and that's equal to 58. And we can now solve this. So to start, we can expand the bracket. So we have 3x plus 2 times 2x gives us 4x, and 2 multiplied by 1 is plus 2, and that's equal to 58. We can now collect the like terms on the left-hand side. So 3x plus 4x gives us 7x. We still have a plus 2 there, and that's equal to 58. We can continue to solve by removing the plus 2 from the left, and we can do this by subtracting 2 from the left and doing the same on the right. On the left, the plus 2 and the minus 2 cancel out to leave us with 7x, and on the right, 58 minus 2 is 56. Finally, we can remove the times 7 from in front of the x by dividing by 7 and doing the same on the right. And on the left, the times 7 and the divide by 7 cancel out to give us x, and on the right, 56 divided by 7 is 8. So x equals 8 is the first part of our solution. We can now take this value of x and substitute it into the first equation to find the value of y. And the first equation is the easiest one to use because we already have y as a subject. So starting with y equals 2x plus 1, if we substitute x as 8, we have y equals 2 times 8 plus 1. And since 2 times 8 is 16, we have y is 16 plus 1, so y is equal to 17. And this means that our final solution to problem 1 is x equals 8, y equals 17. In problem 2, we're solving 4x plus 5y equals 7 and x equals y plus 4. Again, the second equation here is written with x as a subject. And so this tells us that the easiest way to solve this is going to be by substitution. And we can replace the x in the first equation with y plus 4 from the second. So the first equation, 4x plus 5y is equal to 7, can now be rewritten as 4 multiplied by y plus 4, because we know that x is equal to y plus 4 from the second equation, plus 5y is equal to 7. And we now have an equation that only has y's in it, so we can solve it. So we can start by expanding the bracket. So 4 times y gives us 4y, and 4 times 4 is positive 16. We still have a plus 5y at the end of the bracket, and that's equal to 7. On the left, we can now collect together the like terms. So we have 4y plus 5y, which is 9y. We still have a plus 16 there, and it's equal to 7. We can continue solving now by removing the plus 16 from the left, and we can do this by subtracting 16 from the left and doing exactly the same on the right. And on the left, the plus 16 and the minus 16 cancel out to give us 9y, and on the right, 7 minus 16 is minus 9. We can now remove the times 9 in front of the y by dividing by 9 and doing the same on the right. And on the left, the times 9 and the divide by 9 cancel out to leave us with y, and on the right, minus 9 divided by 9 is minus 1. So y equals minus 1 is the first part of our solution. We can now take this value of y and substitute it into the second equation where x is given as the subject. So x equals y plus 4 becomes x is equal to minus 1 plus 4 because y is minus 1, and minus 1 plus 4 is 3. So x is equal to 3. And this means that our final answer to problem 2 is x equals 3, y equals minus 1. In problem 3, we're asked to find the coordinates of the point where the lines with equations y equals 5 minus x and 5x minus y equals 49 meet. Now, if you're ever asked to find the coordinates where two lines meet, what you need to do is solve their equations simultaneously and put that solution as a coordinate. Now, looking at the first equation, we can see that this is written with y as the subject. And so the easiest way to solve this again is going to be to take 5 minus x, which we know is equal to y, and substitute that into the second equation in place of y. So if we do that, we have 5x minus y is equal to 49, becomes 5x minus, and then in brackets, we need to replace the 5 minus x for y, and that's equal to 49. And what really helps with brackets have a minus in front of them is to just put this as minus 1. We can now expand the brackets. So this becomes 5x, and then minus 1 times 5 is minus 5, and minus 1 times minus x is plus 1x, or just plus x, and that's equal to 49. We can now collect together the like terms. So 5x plus x on the left becomes 6x. We still have a minus 5, and it's still equal to 49. We can continue solving by removing the minus 5 from the left, and we can do this by adding 5 to the left and also adding 5 to the right. And on the left, the minus 5 and the plus 5 cancel out to give us 6x. And on the right, 49 plus 5 gives us 54. We can now remove the times 6 from in front of the x by dividing by 6 on the left and doing the same on the right. And on the left, the times 6 and the divide by 6 cancel out to leave us with x. And on the right, 54 divided by 6 is 9. So x is equal to 9 is the first part of our solution. We can now take this value of x and substitute it into the first equation where y is the subject. So y equals 5 minus x now becomes y equals 5 minus, I'm going to replace the x with 9. And since 5 minus 9 is minus 4, we have y is equal to minus 4. Now the problem asked us to write down the coordinates of the point where these two lines meet. Now we know that they meet when x is 9 and also when y is minus 4. So the coordinates where they meet is going to be at the point 9 minus 4.